right, we're about to dive into one of the most mind-bending questions in all of science. Seriously, it's a puzzle that challenges the very nature of reality itself.
I mean, just think about the world around you. Your desk, the screen you're looking at, the moon up in the sky. It all seems so solid, so definite, and, well, it's just there. But what if it isn't?
What if reality is less like a finished painting and more like a sketch that only gets filled in the moment we decide to look at it? And believe me, this isn't just philosophy. This is a genuine, massive problem at the very core of modern physics.
This whole thing has a name: the measurement problem. It's a fundamental mystery that pops right out of quantum mechanics, and it forces us to get really uncomfortable and ask, what even is reality? So, to really wrap our heads around this problem, we've got to shrink ourselves down, way, way down, into the bizarre world of the very small. Because down there, the rules of our everyday world, they completely fall apart. Particles do not behave like tiny little billiard balls.
No, instead, they exist in a state that's called superposition. So try to imagine a particle isn't just here or there, it's literally in all possible places at the exact same time. It's like a blurry, shimmering wave of pure potential, a cloud of possibilities. And right there, that's the fundamental clash. On one side, you have the world we know, solid, predictable, classical. And on the other, you have this quantum reality, a hazy fog where every single possible outcome exists all at once. It's a completely different way of being.
That bizarre cloud of possibilities just hangs there, doing its thing. Until one very specific thing happens. Until we decide to look. And this is where our mystery really gets going. Because the moment we try to measure, or even just observe, a quantum particle, something totally dramatic and completely unexplained happens.
Let's break this down. So before we look, the particle is that wave of potential, everywhere at once. But the instant, and I mean the instant, we perform a measurement, that whole wave just collapses. The particle snaps from being everywhere to being in one single definite location. From all those possibilities, we get one single reality. And this, right here, is the million-dollar question. What is it about the act of measurement that forces the universe to pick just one outcome from an entire ocean of possibilities? Is it the device we're using? Is it us? Our consciousness? The honest truth is, we just don't know. Physicists have been debating this for about a century now, and they've come up with several absolutely mind-bending explanations. You can think of them as the 4 leading suspects in our investigation into the collapse of reality. Okay, first up is the classic, the Copenhagen interpretation. This is the oldest one, the one that's usually taught in schools. It's really pragmatic. It basically says, hey, don't even ask what's real before we look. Reality is fundamentally just a set of probabilities, and it only becomes definite when our observation forces it to make a choice. Then we have a really wild one, the many worlds interpretation. Its appeal is that it's actually pretty simple. It just takes the math of quantum mechanics and believes it, literally. It says the wave never collapses at all. Instead, every single possibility happens, and the universe splits into a new, separate branch for every single outcome. Suspect number 3 tries to take us, the observer, right out of the picture, which a lot of physicists really like. These are called objective collapse theories. They propose that the collapse is a real physical process that's just built into the laws of nature. It happens automatically when a system gets big enough, whether anyone is looking or not. And finally, there's pilot wave theory. This one suggests there's no randomness at all. Imagine the particle is like a tiny surfer, and it's always riding a very real, physical wave that guides its exact path. In this view, there's no collapse because the particle was never in some blurry superposition to begin with. Its position was always definite. It was just hidden from us. Okay, so this all brings up a pretty obvious question, right? If the world is built from all these strange, wavy quantum bits, why does everything around us seem so solid, so classical? Right. Why don't we see chairs that are both here and also in the next room? Why isn't your cat just a fuzzy cloud of cat possibilities until you decide to look at it? Well, the answer has a fantastic name: decoherence. And this is the critical bridge between that strange quantum world and our familiar classical one. Here's how it works. A big object like a tat is never truly isolated. It's constantly interacting with its environment. It's being bombarded by air molecules, photons of light, thermal radiation, you name it. Each of those tiny little interactions acts like a mini measurement, forcing the cat's superposition to collapse almost instantly. The classical world we see is pretty much just the quantum world after decoherence has wiped away all the weirdness.
Now, you might be thinking this is all just abstract philosophical stuff, but you'd be wrong. Solving the measurement problem actually has massive real-world implications. Seriously, our most advanced future technologies depend on figuring this out. Quantum computers, for example, need to maintain that fragile state of superposition to work their magic, so we have to know how to prevent the wave from collapsing. And secure quantum communication relies on the fixed rules of what happens after the collapse. So to truly master this new frontier, we have to understand that line between possibility and reality.
So the measurement problem remains unsolved. It's this deep, fascinating crack in our understanding of the universe. It tells us that reality isn't just some static stage we all walk upon, but something dynamic, something we actively participate in. And it forces us to ask, where is that line? Where does that fuzzy cloud of quantum possibility finally give way to the concrete certainty of the world we know? That question is, for now, the ultimate mystery.